Hello students, in this semester you have two papers, H51 and H52. So from H51 I'm going to teach you Unit 5 and from H52 I'm going to teach you Unit 4. So I'll start with the H52, that is Unit 4. So the first topic of Unit 4 is nothing but it is moment of inertia. So I'm going to explain you what is a moment of inertia. So let us first of all, let us consider a body of mass m. Okay, so this is a body, this is a body of mass m, and this is a axis from through which the body is rotating. I will try to find what will be the moment of inertia of this body. So the moment of inertia of this body, what would be the moment of inertia of this body we are going to find. So let r be the perpendicular distance from this axis of rotation. Let r be the perpendicular distance from the axis of rotation. So this distance should be not any distance, but it should be a perpendicular distance from the body mass m to the axis of rotation should be a perpendicular distance. Then the moment of inertia of this body is given by nothing but mass into perpendicular distance square. That is what mass is m. So m and the perpendicular distance from the axis of rotation is r. So this will be mr square. So the moment of inertia of this body is nothing but mr square. Now if you consider a rigid body, now suppose I consider a rigid body. A rigid body is made up of many particles. Okay, so if I take, suppose the rigid body is made up of this number of particles. Okay, so let us consider a body. A rigid body is made up of n particles, and the mass of first particle, let us take as m1, and the mass of the second particle, let us take as m2, and the mass of the third particle, let us take as m3, and the mass of the fourth particle, let us take as m4, and so on. So in that way, and let us take this be the axis through which the body is going to rotate. Then the perpendicular distance from the body mass m to the axis of rotation, let us take as r1, and the perpendicular distance from this point from the axis of rotation, let us take as r2, and the perpendicular distance from the mass m3 to the axis of rotation, let us take as r3, and in the same way the perpendicular distance from the mass 4 to the axis of rotation, let us take r4, and so on. So then the moment of inertia of this rigid body will be given by I equal to mass. First of all, we try to find what will be the moment of inertia contributed by the body of mass m. So the moment of inertia contributed by the body of mass m is nothing but it is m1 r1 square plus the moment of inertia contributed by the body m2 is nothing but it is m2 r2 square, and the moment of inertia contributed by the body m3 is nothing but it is m3 r3 square, and the moment of inertia contributed by the body of mass m4 will be m4 r4 square, and so on, because as we have n particles, so we have the last body. Suppose if we take the mass of the n particle as mn and the perpendicular distance from the axis of rotation as rn, then the moment of inertia contributed by the body of mass mn is nothing but mn rn square. So we can write this as in the form of summation, that is nothing but I equal to 1 to n mi ri square. So that is the moment of inertia of a rigid body. Now if you want to, we'll try to define what is radius of gyration. So in order to understand what is radius of gyration, suppose I take a body, I take this body, I'm drawing this body. So you know that every body has a center of mass. So first of all, we try to find what will be the center of mass of this body. So suppose I take this is a point where the center of mass lies. Then we know that the total mass of the body is concentrated at the center of mass, means the total mass is present at the center of mass. So if I take the body is of mass m, then at this point the mass will be capital M. And we want to find what will be the moment of inertia above this axis. Okay, Then we try to find what will be the perpendicular distance from this axis to this mass. So this, from this mass I'll try to draw a perpendicular distance. So this perpendicular distance I denote as k, and this k is called nothing but it is called as the radius of gyration. So we'll try to find what will be the moment of inertia about of this body. That is nothing but it is mk square. So that is done for about the radius of gyration. As we'll try to explain about the product of inertia. So to understand about the product of inertia, let us consider two planes. So I'm considering this as my p plane. This is my p plane, and another I'll consider as my q plane. So this is my q plane. So I'll take a point on this. So the mass of this body is taken as delta m, and the perpendicular distance from this mass to the plane p is taken as small p, and the perpendicular distance from the mass delta m to the plane q is taken as q. Then the product of inertia for this is given by, suppose I try to donate by product of inertia about these two plane is donated by p. Then the product of inertia is given by delta m pq, or we can write p is equal to integration pq delta m. If we consider only one mass, then it is delta m, but if we consider the body is made up of n particles, then the mass in the product of inertia will be given by the summation. Now I will try to explain you about the moment of inertia and product of inertia with respect to three mutually perpendicular axes. I want to explain you about the moment of inertia and product of inertia with respect to three mutually perpendicular axes. So to explain this, we'll take three axes. We are taking a point, because we consider a point x, y, z. Okay, and the mass of this point is taken as delta m. So we are taking three axes. Ox as the x-axis, Oy as the y-axis, and Oz as the z-axis. Then we try to find what will be the moment of inertia about this axis. So the moment of inertia about the Ox-axis is denoted by A, moment of inertia about the Oy-axis is denoted by B, and the moment of inertia about the z-axis or z-axis is denoted by C. In the same way, the moment of inertia about the axis OY and OZ is denoted by D, and the moment of inertia about the axis OZ and OX is denoted by E, and the moment of inertia about the axis OX and OY is denoted by F. So in that way, the product of the moment of inertia and product of inertia is given below. So what is this? A is the moment of inertia about the x-axis, that is given by summation delta m y square plus z square. In the same way, moment B is the moment of inertia about the y-axis, which is given by summation delta m z square plus x square. And C is the moment of inertia about the z-axis, which is equal to summation delta m x square plus y square. And D is the moment of inertia about this. D is the product of inertia about the OY and OZ axis, which is given by summation delta m yz. And E is the moment of product of inertia about the OZ and OX axis, which is given by summation delta m zx. In the same manner, F is the product of inertia about the OX and OY axis, which is given by summation delta m xy. Okay, so how do we find, because we know that moment of inertia is nothing but mass into square of the perpendicular distance from the axis of rotation. So if I take this, suppose I consider this one, suppose I consider this, so this I took as OZ and this I take as OY. Okay, I take a point here, so I take a point X, Y, Z. Okay, so that means, and the mass of this body I'm taking as delta m. We are considering only two particles to make it clear about the distance. How do we find? So from here, from this coordinate, we can easily say that x is nothing but the distance of the point of this point from the origin, from the x-axis. Okay, the distance of the point from the origin to the x-axis is x. Okay, in the same way, y is nothing but the distance of the point from the origin to the y-axis is y, and in the similar manner, z is nothing but the distance of the origin from the point on the z-axis is nothing but it is z. So if I draw this perpendicular distance, so this distance is nothing but it is given by z, and this distance is nothing but it will be y. So you know that this is OZ axis and this is OY axis. So in the same way, where will be our Z axis? So the x axis will be perpendicular to this two axis. So this is your OX, means this will be our OX axis. So we'll try to find what will be the perpendicular distance from this point to this axis. So you know that the perpendicular distance will be nothing but this distance. So it is a right angle triangle, so we can apply Pythagoras theorem and we can find the distance for this. So this is nothing but it will be y square plus z square. So this is for a single body, but if the body is consisting of n particles, then it will be the moment of inertia will be given in terms of summation. So if I explain for A, this is nothing but it is summation delta m r, and the delta m mass into perpendicular distance from the axis of rotation. So the perpendicular distance is square root y square plus z square, whole thing square. So square and square root will be cancelled. So we get here summation delta m y square plus z square. So that way we are trying to find the moment of inertia and product of inertia. These are the definition of product of inertia and moment of inertia, and I'm going to discuss about how to find the moment of inertia of a rectangular rod or rectangular lamina, rectangular parallelepiped, circular ring, circular disc, and all in the next video. Thank you.